Hello everyone, welcome to YourPedia Education. So today we are here at IIT Ropar and I got this opportunity to meet Dr. Abhishek, one of the renowned professor in electrical engineering department supervising the VLSI domain. So first of all, Professor, thank you for taking out the time to meet with us today. It's an honor to have you here with us.
Okay, it's my pleasure.
So could you please start by introducing yourself to our audience?
Okay, so I am Abhishek Sharma, and I work as an assistant professor in microelectronics and VLSI domain in electrical department of the IIT Ropar. And our work is mainly focused toward our work is basically, if you take a transistor, right?
Right.
So by the heart of a transistor, what we are doing, we are controlling the charge of electron.
Right.
So, but as you might know, electron has 2 or 3 additional degree of freedom.
Right.
It has charge, it has spin, it has energy,
Right.
and as well as it has quantum nature.
Right.
So by using this just charge of electron by its control, we are able to usher into great era of electronics.
Right.
Now imagine if you can harness the other 3 other 3 degree of freedom of the
Hidden gem of
Yes. So my work is primarily what we do along with the traditional electronic devices. We try to utilize the spin of electron as well as energy as well as quantum nature to come up with a new device design for the upcoming quantum technology era.
Right. So if I'm not wrong, Dr. Abhishek, you are contributing into Spintronics and quantum technology, right?
Yes. So yeah, it will fall under the broader category of quantum technology.
Okay. So see, when we talk about the VLSI and microelectronics in most of the premier institutions, so students only think of analog electronics, analog design, digital design, device fabrication. So these terms might be new for the student at this time, but I'm sure they are the revolution for the coming time. So basically, what kind of fundamental knowledge students need to have to perform and excel well with these research area activities?
Okay. So if you see the global dynamics of the technology,
Right.
So the quantum technology and the spintronics has been identified one of the key area for the beyond Moore era.
Right.
So you might be aware of Moore's law.
Right.
Those of you who doesn't know it, I will just briefly
Definitely.
explain it in one line. So we have this Moore's law, which tell you after every 1.5 or 2 years, the transistor's size goes by a factor of half. So now we are currently reaching a point of, let's say, 3 nanometer technology node. So it becomes impractical or even physically impossible to shrink it down. So what it leads us to a situation that we will reach a saturation point where the electronic devices cannot improve better.
Right.
So now the inevitable fallout of that is you have to look for the other additional degree of freedom of the electrons.
Right.
So that I already explained, let's say that spin, energy and the quantum nature. And when it comes to the skill set required and conventional, it has been a convention that microelectronics and VLSI has been associated with the circuit design and the conventional devices.
Right.
So, but as the government has started this national quantum mission, that means at the highest level of our nation, there is a clarity that as a nation we need to move into this direction. And I see in, let's say, in the conventional electronics, right, we have here design centers and all those things. But if you compare with any other, if you compare with the US or China, right, so we kind of lag behind.
Right. We always follow this.
Yeah. So, but here the good part of the quantum technology revolution is we are on the, kind of marching on the same side by side. So I feel at this juncture, right, so it could be a turning point if we could, really get ahead of the curve in the quantum technology.
Right. So as you quoted that you are dealing here into quantum technology. So let us suppose some graduate is coming for the master's or PhD, having his background in the electrical, electronics or some other engineering. So it's very rare we found that those people have a good hands over the quantum mechanics or quantum physics. So obviously it will be very difficult for them to cope up with the course curriculum and things. So what kind of academic curriculum you people have established here so that they can cope up easily and bridge that transition to the quantum technology?
Okay, yeah, this is a very important point. And as you know, there is an upcoming, revolutionary era that we have ahead of us. So, and traditionally, the device engineers or the electrical engineers are not trained in it, right?
Right.
And one of the hurdle is, knowing the quantum mechanics. But if you go to physics department to reach up to the quantum mechanics through a physics department, it will take you 5 to 6 courses, and it will take you around 2-3 years.
Right. It's a very long journey.
Yeah, so it's a very long journey, very tedious journey.
Yeah.
So, but electrical engineers have, a fair amount of, understanding load matching, and they have a fair model of Fourier transform, linear algebra, right? So what we are doing here, we have established a part in the course, and through some informal groups, right? How to have it's like a quantum mechanics for engineers.
Right.
How to impart enough quantum mechanics, keeping the engineering perspective into that. So that involves basically what we have developed in-house some coding assignment where you can take a quantum mechanics, a problem which physicists will solve, using differential equation. But we have our personal computers are powerful enough to solve them numerically. So that gives you engineering insight and design insight. If I change this parameter, this is how it can be done. And corresponding to that, we teach how you can do it in the electronic devices.
Right.
Because by the end of it, the electronic device is not electronic device is not going to go away.
Right.
It can have a quantum properties, and then it can usher into new era of application, but that foundation will remain same.
The root will be the same.
Yes, so exactly using that approach, we are kind of started this initiative in our group.
So it's quite amazing, Dr. Abhishek. But we are sitting in the country where people make a decision purely on the basis of their career perspective. What ROI they are going to get if they are investing some time into some courses or some graduation things, right? So today students have fear that if they join these technology like quantum technology, Spintronics for PhD or masters. Although for master we don't have a specific specialization for quantum technology in the many places, very few have started. Do you think that still they have the chances to get the jobs in the top MNC like Cadence is there, Intel is there, Nvidia is there, Micron is there, AMD is there, Qualcomm is there, Texas, lot of in the row are there.
Let's say Synopsys or something. Okay, so yeah, this is a very important point, and in this regard, I would say, right, it's like the job is a priority. So the way we do quantum technology, Spintronics, it's not divorced from the existing device.
Right.
So what we do, we build upon the, let's say, regular semiconductor devices foundation. We extend it. We have a natural extension process through various learning processes in the courses in the IIT Ropar curriculum that we have carefully crafted to account for this. And once they know, so it's not their expertise gets shrunk, their expertise gets broadened.
Right.
So they know the semiconductor, and going into this this very niche and highly sought after area. And now coming to the job perspective, I would say it's just a starting. So the jobs, the kind of skill set it is going to impart the student is the companies have already starting to invest in that.
Right.
So if you come to, let us say, I will give you one or two inside perspective from my various interaction with some companies.
Right.
Let's say you come to Synopsys, right? Synopsys has launched a software. It's a quantum ATK.
Okay.
Right? So what they are doing, earlier there was a TCAD software. There was an era of then modeling. Everybody was doing TCAD, but now the era has shifted because all the permutation and the combination in the TCAD is kind of exhausted. And it's there, but it's kind of saturated. And Synopsys, they acquired this software from QuantumWise because this software, what modeling it can do, it can capture all the quantum technologies and the spintronics in a same footing.
Okay.
But the good part and the bad part at the same time is, so they have started it, but it's just in its very nascent stage. So from a modeling perspective, there is a huge market, and even the cadence, I talked to some experts in the cadence, especially in the India team and along with the US, they were very keen to develop their own product.
Okay.
So you can see that the skill set is somewhat, and but what the problem was, they're not finding enough people who are trained to develop this kind of a modeling platform.
That's very true. We have adopted the technology, but we are not nurturing the people to get skilled in those, and so that we can get the output from that. Right?
Yes, and it's straggling and a bit strange that we have, we see ourselves a great IT power, basically a great software power we have, but these very useful software, I will explain why they are so useful in a minute. These software that enable you for a technological transitions, we are not developing it because we don't if we don't invest in the manpower right time, somebody else will develop, and then we will be, we with the quantum technologies, we don't want to really lag behind as we lag behind in the semiconductor.
Many things, right?
Yeah, so we want to sort of account this fact into our conscious and act appropriately.
True. So this was about the postgrad. Now coming to the undergrads, right? So we see mostly in today's high tech or design and deep tech jobs, specialization is required, demanded, because you must be very expert fellow in some specific domain, right? Only then you are going to get a comfortable space to work there, right? But in today's time, we have a lot of courses available on the online platform, or we can say in BTech curriculum, there is nothing like that. You are guided and mentored specifically from the research point of view. So as an individual, as a professor here in IIT Ropar or as a IIT Ropar institutions, what all key initiative you people are taking to foster the culture of research among the undergrads so that they can become highly skilled and they can also think of some deep tech jobs?
Okay, yeah. So as you rightly pointed out, right, most of the courses, one can even argue what's the point of doing BTech, right? I mean, saying if I say it frankly, right? But one thing, the amount of learning and the culture IIT provides that, and other thing, keeping this point in mind, and you have a lot of good resources online available, right? We agree with that. So keeping this in mind, we are we are in initial phase, and we have starting a new initiative called undergrad research program. Okay. So this is especially would be interesting to the undergrad who join here.
Okay, so it will be not optional, or it will be mandatory?
So it's not a different BTech program.
Okay,
it's like you join in the existing regular BTech program.
Okay,
and after second year, what it gives you additional option, because a BTech student has enough bandwidth in the summer vacations, right. Winter vacations, and sometimes they have some bandwidth to work around.
True.
So we want to utilize that whatever bandwidth they have to train them into some deep tech areas. Right. Let us say you have a very why the research term is hyphenated with it, right? Because most of the jobs, let's say particularly the design job, they require, let's say vis-a-vis, let's say you take a device design or a circuit design, right? Because my expertise in that, so they require some hands-on experience. Right. Or let us say you want to get into some design, let's say. Right. Since many people know about the circuit, I will give, let's say you want to get into some circuit design company. It would be great, you will have great insight if you have developed a full-fledged circuit, taken its tape out, done a measurement. But this process is so lengthy, you can't do it in a BTech. Right. But if you have that experience, then you will have a very great insight to develop a new circuit. Right. So given that requirement, there is a requirement for you have a common BTech understanding and then a very specialized expertise in a particular area. Right. That's the demand of the industry.
Very true.
So given that thing, so we are coming up with this undergrad research program where what we will do, the students will be mentored by the faculty, the interested student, after the second year.
Right.
So they will have around 2.5 and 3 years, along with their coursework and along with all the extracurricular activity. They can, really start to engage with the MTech, existing MTech and PhD student, along with the faculty mentorship, to work on a project which can give them a tangible output.
True.
Tangible output, I would say, it could be in terms of some publication, some patent, or some startup, some deep tech startup.
Right.
I mean, what happens? A BTech guy do a lot of activity, right? And then he has many pointers in his resume. I did this.
Right.
But if you have one tangible output, you go to any company or you go to any, let's say you want to go to some Ivy Leagues of the US or some great universities of the world. If you have one tangible output, one line of a tangible output outweighs all the 10 activity that you might have done.
Yeah, it's very true. Most of the time I see people putting a lot of skills in the CV. Until or unless you're not showcasing them that this is the thing what I have produced, I have done.
Yes.
So you don't mention a lot of keywords. How professor is going to get the credibility of those keywords? You know this language, you know this software. Until or unless you're not mentioning your work, that okay, with these tools and technology, I have make this output, this is my end result.
Yeah, and it's there in the public domain. Let's say you publish one conference paper, one journal paper, one patent, or let's say you started a startup, right? So then it's everywhere. It's like, it's like there is no proof is required to see the sun.
Right. True. That's a very nice thing, right?
So now this is the sort of initiative we are going to start here.
So now coming, Dr. Abhishek, next to the master student, post-graduation students. So we are sitting in the highly densely populated country, right? So here most of the time student, when they are deciding about their master courses, so in India the prime factor is their placement and career perspective, or their ROI, what they are going to get after joining this course. So if I talk about VLSI department of IIT Ropar, what is the placement stat of the past?
So past, especially coming to the VLSI of microelectronics, we have 100% placement. That is particularly in core job.
Okay.
It's not some
great.
Yeah. So we have and for this to enable it, train our student along with the industrial, point of view, and they have a skill set that is, transferable to their industrial job. So we have this initiative, I guess, already going on, is a joint master thesis.
Okay.
So here a person can go for a 1 year after. So our coursework is built in such a way that you can complete all the coursework in a 1 year.
Okay.
Then you can go for a 1 year internship.
Okay.
In 1 year internship, it's a joint master thesis. The thesis will be whatever your industry manager is, along with the your MTech guide.
True.
So your the problem statement also will eventually be somewhat very relevant to the industry.
True.
So most of these cases, these students get because some student, they go to industry, they come up with some good nice problem, and the problems become really relevant, and then most of the students gets absorbed there only.
Okay, they will get PPO there only.
Yeah, so in that way, our placement scenario are, we are pretty happy with that.
That's great. That's great. So Dr. Abhishek, tomorrow, let us suppose there are some students who have done some, deep work in quantum technology or Spintronics. And if they want to approach you, they want to work under your supervision, how they can connect you? Be it in terms of the internship, be it in terms of some project position, or be it in terms of some other modes.
Okay, so actually I'm for undergrad students of other colleges. So I have also, I offer 6-month internship.
Okay.
They can, after the BTech last year, they can join me.
Right.
And coming to the basically MTech or interested, those who want to really pursue the PhD or research in that direction, they can always drop me a mail.
Okay.
And depending upon student interest and his background, generally guide appropriately.
See, very fundamental requirement is you must have the clarity of the basic subject. If we talk about the VLSI point of view, analog electronics, digital electronics, electronics device, semiconductor physics, solid state, these are all the same terms. And network theory or circuit analysis, these are the fundamental subject. But in today's time, students are not getting that luxury that every student is studying from the expert faculty like you. Because to enter into IIT, we have a highly competitive exam. So not all are able to compete and qualify the exam. Still, there are many people who are doing their engineering from local, state, central universities, but they still want to enter into IIT for MTech and PhD. So what is your view that from where they should start preparing and get the absolute clarity of the fundamental? What is your take on the NPTEL?
Yeah, so I feel this NPTEL, I mean, so there are two things. So I would say, so there is a gate, cracking gate,
Right.
and then there is a depth knowledge.
Right.
So generally, the gate syllabus is broader.
Right.
You have a whole BTech covered,
Right.
literally whole.
Dominating subjects are
Yeah, and when it comes to MTech, when you join a MTech, you kind of specialize in a particular area.
Right.
So my suggestion in this is you do the gate well, and NPTEL you should at least whatever area you want to get in, those courses you should surely do it from the NPTEL, and if possible do it as a certification,
Right.
because then you have to give an exam.
Right.
If you don't give an exam, say I will read it on my speed, then it's going to be always on the some back end burner.
That effective output will never be there.
Yeah, so you have to do some, you have to get a tangible output in some certification.
Right.
So that will, you will develop a great insight.
Right.
And when you join a master here or PhD, then you will see you are far ahead of those students who are just prepared for GATE.
Right.
Because I have, nearly taught 5 or, many courses to MTech people, and those who have some real keen interest in a subject, their insight are much different from the just by a GATE preparation.
Right.
Because the GATE has this breadth
there
also,
you
right?
need to prepare
So,
from the theoretical aspect.
yeah, you
Design
have breadth
aspect is
also.
something-
The content is very broader.
Right.
So you have to, let us see, if somebody is interested in microelectronics, but going to the GATE only preparing the device and the circuit, it's not good enough.
Right.
You have to do control, you have to do communication, you have to do electromagnetics.
Yeah, you have to do other stuff also.
Yeah, so in that way, I see the GATE is good to sort of, in a first level
For filtering purpose.
but to develop expertise, you need to do, I highly recommend doing this certification program for the end.
Right. So as we know, our academic session mostly end in the June, and when student is going to start his masters or PhD, they start in the summer session, August. So they have a very good questions of the 2.5 months. So if somebody is willing to start his post-graduation or PhD in quantum technology or Spintronics, so what will be a brief piece of advice from you how to utilize that time? What are the basic subjects you should go and have clarity, and what kind of language, tools and software at least you must be knowing?
Okay. So, yeah, given that, if you go a traditional way into the quantum technologies, so if you go traditional way, what you will find the most of the courses from the physics department.
Right.
And let's say you go to first quantum mechanics class, there you will feel ki I don't know classical, so I should do classical. So then it becomes a kind of loop, and you are and then person leave behind the thing. So here, the way we have, structured the things, we have, created it especially for the engineer perspective, right? So what we want, it's not necessary. I mean, if you want to read it, you are welcome to read the whatever existing. But our main emphasis is if you can, do a numerical calculation or a numerical simulation using, let's say, Python or MATLAB, right? Then you will develop a better intuition by playing around.
Right.
So my recommendation would be, those who want to do physics, I'm not saying don't do it, but my recommendation is you should put some effort into learning let's say, Python, because it's freely available, so you don't have to get, and especially if you, because why I'm saying is, given that quantum technology is the era in front of us, right? And I will give an analogy to make my point, right? So let us say you are a civil engineer,
Right.
and you want to make a bridge.
Right.
So how many iteration you will take?
Once, only once.
In one shot you will make a bridge.
Right.
It's not like that you are going to make bridge, break it, make
Yeah,
it.
make
It's not. The primary reason for that is we have a great AutoCAD software or StatPro. I mean, we have great software which can simulate the whole set of equations. Basically, by the end of the day, you need Newtonian mechanics that can simulate that properly and give you a design that you can put it on the road and make a bridge.
True.
Right. But when it comes to the quantum, so it's a challenge and the opportunity at this.
Right.
In the quantum tech, basically, the issue major from the perspective of modeling is we have great engineering product would be possible when we have great modeling. Otherwise, it's a hit and trial. You can't expect a great innovative product unless you have a great modeling.
Right.
So, but the issue when let's say you want to make a new device, and so you want to make a functional device which you can use it for further circuit development. So can you guess how many iteration it will take?
Many, multiple.
Yeah, it may take sometime years to develop.
Right.
And the reason is because we can't really go ahead with the Newtonian physics.
True.
And so we have to inculcate the concept of quantum, device physics, semiconductors, materials on the same footing.
Right.
These concepts can't be in a different footing. They have to come under the same footing.
Right.
So in our group, and when you put so many complexity on the same footing, what happens? The equations becomes kind of untrackable to solve.
Complex things.
Yeah. So here our group has a unique approach. We use basically some AI and ML algorithms to solve it. To create a AI and ML enhanced, softwares for predicting devices, really functional devices. Then that objective is to reduce the minimum, that life cycle of a new device.
Right.
And it will, let's say you take a device from 0 to making a functional, took 3 years. If we can bring it half, then imagine the amount of economic ramification it is going to have in society. And given that we have a software edge in the India, right? We say our manpower is very well versed with the software edge. So I think as it's best to capitalize that. And in that way, now coming to your prime question, what should they learn? I would say in this area, even if you feel quantum is difficult, don't worry, learn at least programming, so that if coming to IIT Ropar, if you know that programming skill is there, you can always pick up these things. And then a traditional programming has been for some application oriented for CS,
right?
But what we are sitting an electrical department. If you see behind me, there is a physics, and on this side I have a computer science. So we are in a really symbolic way on the intersection of physics, computer and electrical engineering. So it's a highly kind of a interdisciplinary nature, but the amount of promise it has, and given that the whole world from any country which has some good amount of finances from given US, China or Europe, so it's the right time to get into this technologies.
Right, that's great, Dr. Abhishek. So as you quoted that AI and ML are there, right? So today's these technology are creating buzz. Earlier it was the VLSI, students go after the VLSI, but today there are three pillars: AI, ML, VLSI. Students are even leaving the VLSI for AI and ML because of the good job perspective they are getting. At the same time, there is a fear among the student that will VLSI survive for long? Is there any kind of the signs we have that AI and ML will do automation for VLSI and people start losing the job?
Yeah, so it's a very valid fear. And so if you see, right, if you take a AI and ML algorithms, right, basically they have some set of algorithms,
right,
and the boom happened because of the VLSI,
right?
Because these algorithms were sitting in the shelf from last 40 or 50 years. These algorithms were already existed, But the problem was there was no computation machine on which you can run those algorithms, right? So after this, NVIDIA launched their CUDA, right? You might so those
Right.
yeah. So then what happened? It enabled parallelization of lot of algorithms and making them possible to run. But if you see the NVIDIA graphics card, right, which basically I'm quoting NVIDIA only, but there are AMD and all those things. I'm just kind of, this is the leading, so that's why it's not. Don't take it as a.
No, it's true. It's true. No, it's true.
So yeah, so it's if you see that, so by the end of the day, it boils down to the VLSI design in that. Designing a graphic card, and if you see the Semiconductor Research Corporation, it's a consortium of many companies, top-notch.
SCRC.
Yeah, SCRC. So one of their sort of target is by 2030 is get a better this GPU accelerator. Use VLSI devices and the design to get a better and better accelerators. So now you see, so this design, now one question is come to why we can't do it from the AI and then get done, right? That's a fear. But it's then I already told you like amount of complexity involved in the design. So it will have quantum effects, it will have huge device physics, and the set of equations becomes really expensive to solve it by brute force. So I see the upcoming era of it's not going to be AI and VLSI becomes a obsolete. I see the era of AI accelerated VLSI. So
absolutely true.
So what will happen? You will have. So that's why our group started in this direction. How to use AI and ML algorithms to make a better simulations. Once you can simulate and predict device, then you can always go for a fabrication.
Right.
And as an example, right, earlier there was a trend, the fabrication and the design used to be there together. Let's say if you go to Intel, they have the fab facility
and design
on the same floor.
Right.
But if you look at the NVIDIA is such a big company without any fab.
They are on the design only, right?
Yeah, so they are the fabless company. So so now you can't replace that whole design thing just by some algorithms. You need to you will get an edge over the design. Whatever you used to design over 10 days, you may be able to design it over 5 days. But this skill set is going to even further the interest of VLSI.
Right.
Because as I already told you, traditional VLSI, we just control the electron charge, only one thing.
True.
Spin, energy, and its quantum nature. 3 things are still unexplored territory. It's like you are exploring the Earth, you have just found the one continent.
Right.
3 continents are still lying. So with the AI and ML, it's like you get a faster way to explore them.
True.
So I guess the future of VLSI would be brighter than the existing one.
Great. It seems, Dr. Abhishek, there is a lot to look forward to, but it's a wrap-up time. Your insights have been truly enlightening, and I'm sure they will inspire researchers, and you are willing to join IIT Ropar in coming time. So thank you for giving your time. Thanks a lot.
Okay, thank you very much.